Hi, I'm Michael Enright from the University of Washington, and today we'll be reviewing some introductory steps on how to use a Schlenk line. So here we've got in Nano ES 180, we've got a Schlenk line that has a dual manifold apparatus, which means that this front line here is dedicated to our inert gas source, which in our case is nitrogen, and the rear line, which is the larger line, is for vacuum. Attached to each of these lines is a set of 4 ports. Each one connects both to our nitrogen as well as to our vacuum, and you can open and close these ports by simply revolving in and out this stopcock. If you pay close attention to the white ring around the outside of the glass piece here, you can see that it's closed when you see a little bit of that white rim. In order to open it, all that you need to do is back out the stopcock just enough so that you no longer see that white ring, indicating that there's no longer a seal. To close, you need to close it just enough so that you start to see that white ring come back. You don't need to over tighten this, you just need to see that white ring in order to indicate that it's closed. If you over tighten, you risk breaking the Schlenk line by snapping off some of the glass pieces here that help operate that stopcock rotating in and out. If we look at our nitrogen line here, we can go back and trace this back to the source, through this bubbler and out here to this line. The nitrogen gas comes in through source gas 1 and is actually overpressured at about 60 psi so that it can help operate some of the other equipment in this lab. We only want to have about 1 psi output for our Schlenk line for operating syntheses. So we have a down converter, which is pressure gauge that down converts our pressure from about 60 to about 5, and then we adjust it manually from there. So in order to turn on the nitrogen, first turn on source gas 1. You can turn this all the way up, and you'll notice that the pressure gauge is going to read somewhere between 5 and 10 psi. It's currently closed because the ball valve is closed here, and it's pointing upwards. In order to we will then gently open the ball valve and watch the bubble until we start to see a faint small amount of bubbling in our nitrogen bubbler. Once you've established the gentle bubble on the Schlenk line, we now go to the other end of the Schlenk line. We can follow the gas going through the top of our manifold, along the nitrogen line, and it comes to this stopcock at the end. The stopcock is currently closed, but connects to a second output oil bubbler. We're going to then gently open the second stopcock, just enough in order to start to see some bubbles exiting. When we see this gentle bubbling of our output oil bubbler, we now see that we're sending nitrogen through our entire front line and effectively purging our inert gas line with nitrogen gas. We'll now work on setting up the vacuum component of the Schlenk line. First, you'll need to set up 2 glass traps, in order to remove any solvent or contaminants from the Schlenk line and establish a really nice vacuum for your setup. So there's oil there's residual grease left over from before. What you want to do is carefully take a small finger and wipe that oil around the grease around the outside in order to enable a nice, tight, air-free seal on both of these ports. You'll then attach 2 clamps, one to either side, and tighten the clamps, turning clockwise in order to prevent them from reopening accidentally. So clockwise or counterclockwise? Depends on your point of view. Next we'll set up the second one. This one doesn't use grease, but rather uses an O-ring. You'll place the O-ring on top of the trap, Set the trap up into place and place your clamp around the outside. You'll want to then move the clamp so that it points to the, so that it's moved towards the back, so that you'll have a place in order to pour liquid nitrogen so the clamp doesn't obstruct your ability to pour. Once you've got the two traps up, you can then turn on the vacuum pump. The way you can turn on the vacuum pump is actually with a light switch located right under here. Simply turn it on and your vacuum pump will be operating. There's actually, you might not be able to hear it in the video, but there's actually a faint whooshing sound which is indicative of the pump actually pulling in air from the outside environment. And that's because we have this vent port currently open. In order to use this, in order to use the pump to establish a strong vacuum in our Schlenk line, we'll need to close this port and open the set of traps to the rear vacuum line. So we'll open this stopcock as well. And looking at our pressure gauge, we'll see the pressure will begin to drop if everything has been set up correctly. Places that most regularly lead to leaks and an inability to pull down a strong vacuum tend to be those joints where we just set up that had grease on them, located here and here. Dust or hair or other particles around the O-ring, or up here where the vacuum gauge actually measures the pressure. Sometimes that over time gets a little bit loose and opens a little bit of a leak into the vacuum line, which prevents us from establishing a nice strong vacuum. You can see here that we're pumping down to about 150 millitorr. Once you achieve about 150 millitorr, you're then good to set up a pair of liquid nitrogen dewars in order about the traps. To set the dewars up, I slide the dewar into place. There's a chain that wraps around the back and connects in to this gray pin on the side. You'll then turn clockwise to tighten this chain in order to secure the dewar into place. You will then slide the support into place in order to have an extra bit of security to prevent the dewar from slipping out of the chain in case it's not tight. We'll do the same for the second trap. Tighten it into place and secure the additional frame support. By now you'll see that the pressure has fallen close to about 100 millitorr. At this point we can then supply liquid nitrogen to the traps. Now the traps here are have a thin frame that actually has a vacuum inside the middle. So you can see it's vacant. We've got a location where we can pour liquid nitrogen in, but then this frame is actually hollowed out in the middle with a vacuum that allows us to insulate the liquid nitrogen that goes into the dewar from the outside surroundings. So we'll fill this with liquid nitrogen and use this dewar to fill up the two around the traps. When pouring liquid nitrogen, it's important not to pour it inside your shoes or gloves, as that poses the greatest risk to damage to your skin or to having frostbite. But otherwise, liquid nitrogen, if it does come in contact with you, you don't have to worry, as it will evaporate almost instantaneously. Once you have liquid nitrogen in a pouring dewar, carefully add it to each of the 2 dewars around the traps. And spilling a little bit is very common, so don't worry if you spill liquid nitrogen. Even with just a little bit of liquid nitrogen, we can see by the pressure gauge that we've already started to decrease the pressure in that vacuum line. Continue to fill the 2 dewars on the Schlenk line until the pair of dewars around the traps is nearly completely full, upon which you'll see a lot of bubbling around the outside. Once you have filled the traps, you can take a piece of pig mat with a binder clip and wrap the pig mat around the glass trap, including the dewar base, and clip this into place. This allows us to insulate the liquid nitrogen and prevent it from evaporating quickly throughout the experiment. Starting from full traps full with liquid nitrogen and using this insulation, you should be able to have enough liquid nitrogen to last at least 8 hours of Schlenk line usage. Now you're ready to use the Schlenk line for your experiments. Oxygen condensation is the biggest danger that you have when using a Schlenk line. And what oxygen condensation is where you have oxygen, usually from the environment, that gets sucked into either of the traps and actually freezes into, condenses into a solid blue species that is then highly reactive and can actually lead to explosions, even with materials that are considered usually inert, such as Teflon tape, or even a little bit of grease that may have dripped down from the sides of the trap here. Some common places on where you could have leaks that could introduce oxygen condensation are usually up here at these 2 points on the traps of these seals. If either one comes loose during usage of the Schlenk line, you can introduce a small leak that will suck oxygen into the traps and you may not notice it. Additionally, if this O-ring is not forming a great seal, you could have condensation of oxygen from here as well. Another place the other most common place is if you leave one of these rear vacuum ports open in the back, that you could actually be sucking oxygen in from the environment that readily leads to condensation here. And this will happen over prolonged periods of time. So 1 second open to oxygen won't lead to condensation. However, if you leave it open for the course of minutes, then you're likely to condense a significant amount of oxygen into your tubes, which could lead to a dangerous operation when taking down your Schlenk line. Another trouble spot is when connecting your tubing to your apparatus for that you're going to be using for your synthesis. If that connection is not well connected, then you could actually have a leak that condenses oxygen in your traps. For an example, I'm going to show you what happens when you open up a rear vacuum port when your rear vacuum port when your pump is going and you have liquid nitrogen in your traps. you'll immediately see a large pressure spike, as well as you'll be able to hear the pump working hard to reestablish a strong vacuum. I immediately closed the port, but you can see that the pressure jumped up very rapidly. If ever during your experiment you have a situation where you think that your reaction vessel or your line is completely under vacuum, and you see a pressure up here around 5 torr or above, that's a good indication that you have a leak in your system, and immediately close off all of the ports on the back, as well as the port, as well as this port here to shut off the Schlenk line from the rest, from being able to continue to pull oxygen or wherever the source of that leak is into your traps. If you're concerned that you may have condensed oxygen while using the Schlenk line, this usually will happen when you're taking down the traps. And while taking down the traps, you do see that opaque blue species that you believe could be condensed oxygen. Immediately replace the trap if possible. Reach down, shut off the vacuum either on the pump itself down here, or the light switch, whichever is easiest. Open up this port in order to try to vent this area, and immediately close down the sash to the bottom. Then tell any other people working in the hood or in the area that you're of your concern and that they should stay away from the hood, and inform a TA or professor of the concern.